Welcome everyone to our webinar today entitled Scanifly Software, Drones, 3D Mapping and LiDAR and Solar. Thank you for joining us. We had a record number of people sign up from over 85 countries worldwide. I think you're going to find the next hour and change very interesting. We are ecstatic to share with you about this topic. Scanifly has trained over 700 people with these NABCEP tailored materials, and this is by far our biggest cohort. On this webinar, you can expect to learn a variety of things. How to leverage drones for your solar operation. How to get a drone pilot's license. What drone to buy. How to fly it. What is 3D modeling software and photogrammetry? How does this relate to LiDAR? And how do you put it all together to save you time and money and increase your safety and accuracy for each project you work on? With that in mind, I'm going to turn the presentation over to my partner and colleague, John Novak, who will take it from here.
Okay, great. Thanks, Jason. And thanks everyone for joining us today. So we have a lot to cover. So first we will talk about those challenges with assessment and design, followed by an introduction to Scanifly. Then we will revisit those challenges with assessment and design. Then we'll talk about how to get started in incorporating drones into your workflow, followed by a software demonstration, then a Q&A. All right, so before we get started, let's start with a poll. How accurate do you find satellite imagery and satellite imagery-based tools?
So we see that about 83% of respondents said that it's just okay, but we need to verify on-site data before an installation. That's more or less in line with a lot of the conversations that we've been having. It's reflective of the industry trend, I think. It is interesting that about 10% people are seeing it as perfect accuracy. It's possibly that they're located in a more urban area or an area that's updated more frequently by Google Maps and others. But that's also interesting. And then, completely unreliable is another component. Again, we know this is geographically specific and also workflow specific, but it's great that you provided this insight.
Okay, so let's talk about those challenges with assessment and design. Satellite imagery can sometimes be pixelated. It's lacking those Z-axis dimensions. It's really hard to tell what's going on site, and it's lacking some of that three-dimensional real-world context that's needed. Okay, then there's designing for new construction. So if the building has not been constructed yet, sometimes it's very difficult to design for that project where the building is not included yet on satellite imagery. Okay, so next, the shade impact from surrounding objects. Okay, so if the objects that are surrounding the area that is proposed for solar, if it's not assessed properly, right, then it's hard to determine the shade impact there on the area that's proposed for solar. So the example on the left-hand side there's a church that has a lot of potential of casting a shadow on the roof plane that's proposed for solar to the north. And the example on the right-hand side, it's very hard to tell what's going on there on that industrial site there in the center there where the circle is. Okay, so then there's designing for solar carports. Okay, so the example on the left-hand side, it's just rectangles overlaid satellite imagery. Okay, so it's hard to tell if the vegetation to the southwest there, if it's just dormant deciduous shrubs or trees there. It's also lacking that three-dimensional data there. It's just a flat 2D plane in the satellite imagery. The example on the right-hand side there, designing for ground mounts, right? Again, just designing on a flat 2D plane there. It's hard to tell what's going on there with the topography, but this is in fact this is a capped landfill, so the topography is changing there. So we need to take that into account. Then there's the obvious, right? So climbing that ladder, getting up on the roof and keeping your balance there with the measuring tape, right? Acquiring all of those dimensions by hand while you're keeping your balance on the roof and staying safe, harnessed in there. Very, very, very challenging and not very safe, obviously. Okay, then there's walking around the site as well. So for those larger commercial projects, okay, sometimes it can be very difficult and just challenging to walk the site. It could be a challenge. Okay, so then there's getting up on the roof after a snowstorm, right? And nobody wants to be doing this. This is very dangerous. You know, no need to be risking your life to for obtaining those those measurements there, whether they're shade readings or just dimensions there. So super dangerous. Nobody wants to be doing that. All right, so drafting 3D models from scratch, from hand sketches here. Sometimes this can be a challenge, right? If we're using those hand sketches as a reference when we're extruding those 3D environments that we're building, they're using remote tools, right? So sometimes those hand sketches are hard to read, and the 5 looks like an 8, 8 looks like a 5, and sometimes those right angles are missing when we're trying to create roof planes like this one here on the bottom left. So sometimes this could be a challenge. And okay, so then there's the on-site shade analysis tools. Okay, so sometimes, you know, with the sun glare, you know, the obstructions are not captured correctly, or just captured at all, really, in those view sheds when you're capturing that data on site. So this for this view shed here, you can see that there are 2 trees here, and if you look on the right hand side here, it's hard to tell exactly where the tree is ending there, and really this yellow area should be green, and you know, that solar axis percentage is going to change because of that, and thus the production is going to change as well. Okay, so a little bit about me. So I experienced these challenges firsthand working in solar. I started working in solar in 2011 as a PV system designer, and started working as a senior designer as well after my role at GeoPeak there. I'm also a Part 107 pilot. And yeah, so I've experienced these challenges firsthand, and my teammates, my co-founders, have also experienced these challenges firsthand in solar, and they have been in the solar industry for a while as well. So how can we tackle these challenges that I mentioned here in solar? So PV system designers need this real world context when designing and assessing the site. So we can obtain that real world context. We can design with that real world context if we capture reality using a drone, right? We can then design and analyze using this 3D mapped environment, right? This 2-scale virtual replica of the property. This way we have all of the information that we need. So really cool. So how can we 3D map the property, right? So there are 2 different 3D mapping methods. So one is called photogrammetry, and the other is using LiDAR. Okay, so photogrammetry, right? You're creating a 2-scale 3D model, right? Using images. So in this case, right, we're using images that are captured using a camera that is attached to a drone, and using kind of a batch of images here. We can create that 3D model that you see on the right hand side, and then add modules, perform a shade analysis, and perform all the PV system design tasks in the Scanifly software there. So super cool. So here are a few examples here. So the example on the left-hand side, you can see that there's a ton of detail here. So on the facade of the building here, you can see that there's the meter, and there's the panel. You could see the Spanish tile here. So there's a lot of detail here with the photogrammetry method. And the example on the right-hand side, you can map with vegetation. Okay, in this example here, you can see that because we have this 3D mapped environment, we can import the additional 3D models into this 3D mapped environment. So for this example, the homeowner wanted to see if that inverter will be in the way as they're walking from the driveway or from their car to the gate there for their backyard. So really, really cool. Okay, so the next method for 3D mapping is using LiDAR, right? So light detection and ranging. So LiDAR is just 3D mapping using lasers and also other sensors. So the image on the left-hand side, that is a LiDAR-based 3D scanner that we developed here in-house. And the image in the center there, that is some raw data from that scanner. So that is, there's depth data there, there's reflectivity data, and the image on the right-hand side, we've fused that reflectivity and depth data with the camera data, right, with the RGB data, and fuse those together, and now we have this virtual replica of the property where we can then design the PV system. So now with LiDAR, right, with that LiDAR-based 3D scanner attached to the drone, right, it's at a lower altitude there. And because of that, and also the sensors as well that are in the scanner, we can produce this very dense LiDAR-based point cloud that you see here. And there's a ton of detail here that you can extract. So there are tree branches, there are parking lot lines and curbs. Right? There's a ton of detail here. So this LiDAR data shouldn't be confused with the LiDAR data that is included in remote software, right? That LiDAR data comes from a 3D scanner that is attached to a manned aircraft, which is at a higher altitude, and thus produces a very sparse point cloud. So, you know, the result of that is a very jagged looking mesh, and jagged looking data, and it's not as dense as you see here, which is because the scanner is a lot lower to the ground there. All right, so Scanifly was born out of the idea of using reality capture and 3D mapped environments to accelerate project development and bring that real world context to the assessment and design process. So super cool. So you can see here, this is a project in the Scanifly software there, where we have this 3D mapped environment and modules added there. All right, so since we have this 3D mapped environment, right, we have this virtual replica of the property. This really gives you the opportunity to wow your customers by showing them what this project looks like on a virtual replica of their home or business. So when your customer has 5 to 10 proposals on their dining room table or their conference room table, that they all look the same. They all look like rectangles overlaid satellite imagery, extruded 3D models, right? Your project, right? Your design will really stand out because it's the one that has a virtual replica of their property with the modules overlaid. So really cool. So it really gives you that competitive advantage there. Okay, so you could design for any type of project, right? So since we have this 3D mapped environment, right, we can import other 3D models into this 3D mapped environment as well. So that includes ground mounts, right, with the fence around it. It includes solar carport structures, and these are all to scale 3D models that you can import. And also custom canopy structures. So if you have a canopy structure that you have designed in SketchUp or Autodesk Revit, or any 3D modeling software really for that matter, you can import that into the 3D mapped environment, which is really cool. Okie doke. So poll question number 2, when does your company conduct its first physical site visit? Your technical on-site survey.
All right. So we see about 40% of people are doing a combination of before and after, depending on the site. I think what's very noticeable is 39% of people are going before closing the sale. That is close to the highest number that we've seen on presentations that we've done. Typically, there's more of a combination of before and or after. But I think the takeaway that we're seeing as a trend here is the majority of people are relying on satellite imagery to an extent, which is how you're able to go after closing the sale. But nonetheless, there's still a necessity to see the site for yourself, to verify data, and make sure that that's communicated accordingly, both to your team internally, but also to the different customers that you're interfacing with. Also notable, and what we've also seen, is very few people are rolling a truck for the first time when it comes to construction, a technical truck roll. We have heard of that business model, but increasingly it's not something that we're seeing be feasible. So great. Thanks everyone for your feedback. We've got a couple more of these coming up. Back to you, John.
Okay, great. Thanks, Jason. Okay, so let's revisit those challenges in solar. Okay, so the satellite imagery, right, super pixelated, hard to really tell what's going on site there. The image on the right-hand side, that is a 2-scale virtual replica of that same property that you're seeing there in the satellite imagery. There's a ton of detail on the image on the right-hand side there. The obstructions are there, the facade is there, the chimney heights, those unique roof planes that are there. Everything's there, including the surrounding environment. So super cool. All right, so then there's designing for new construction, right? So including that building there in the satellite imagery. So you know, we can go from not having any imagery or any the building included, excuse me, in the satellite imagery to 3D mapping that area and placing that 3D model on top of that satellite imagery, and thus you can design in Scanifly. So this is a great opportunity here where you can kill 2 birds with 1 stone, where you can really embed that PV system with the home when it's under construction, right? You can hide those conduit runs, junction boxes there, and it's great to install the PV system when it's under construction. So this way, when the house doesn't complete the construction, then the PV system starts the construction after that. So yeah, it's great. You can 3D map the building when it's under construction there. You can still see the home wrap there for this building. So next, the shade impact from surrounding objects, right? So that church that was to the south there, the image on the right-hand side, you could see that because we 3D mapped using the drone, we have the contextual information there, right? We've 3D mapped that church as well as the building proposed for solar there, and there's going to be a ton of shade coming from that church here. You could see there's a lot of shade that's going to be casted on this roof plane here. So it's super important to capture that surrounding environment as well as the area that is proposed for solar as well. Here's another example of that where this is a industrial site where if you were just using remote software, it's hard to tell exactly what's going on here in the center of these two buildings. There's some industrial equipment here, and you know, since we 3D mapped the area there, we have this building and this tower here, which is going to be casting a shadow on this array, which does impact your production there. So super important to capture that surrounding environment, right? So you do have that real world context when designing. Okay, so next is designing for solar carports, right? So instead of designing on a 2D plane where you have rectangles overlaid satellite imagery, you can have a 3D mapped environment with all the Z-axis dimensions. Here we have the vegetation is included, and you can see that this carport to the left-hand side here is, you know, it's going to be in the shade. So it's not a good place for the solar carport unless you're going to cut down those trees there. So next, designing for ground mounts here, you can see that the example on the left is just that 2D plane with rectangles overlaid with satellite imagery, and in Scanifly here, the arrays they track the topography, right? So you keep the topography in mind when you're designing. And here's another example of that, where you can see the inner row spacing, the shade for the inner row spacing there. When the topography changes, you could adjust that, which is really cool. So next is the obvious again, right? So climbing up on that roof, right, and walking around the site, right? Who wants to do any of that when you could just have a autonomous flying robot capture all of the data you need in just a few minutes. So site measuring, okay, so keep your boots safely on the ground. No need to measure the site. With the measuring tape, you can measure anything and everything in the 3D mapped environment. Okay, you can measure tilt angles of the roof planes there. You can measure Z-axis dimension there, right? So the HVAC heights and tree heights, and pretty much anything that the ruler can grab onto in Scanifly. Okay, so the obvious again, right? Nobody wants to get up on the roof with the snow there. So if there's a light dusting of snow, you can still 3D map. So the image on the right-hand side there, that's a 3D mapped environment there with after a snowstorm, and so even after a rainstorm too, super slick. No need to get up on the roof there. You could still 3D map even after a rainstorm as well. Okay, so the on-site shade analysis, right? So Scanifly is that bankable shade analysis, right? The other bankable on-site shade analysis tool there, where you can generate these solar access view sheds from anywhere within this 3D mapped environment and export a shade report PDF. So really, really cool there. And you could also cut down trees or just remove pretty much any object virtually. So you can really see what the production change is going to be before the customer commits and before the tree service goes out to cut down that tree. Then you have to go back out to the site there. So no need to do any of that. You can cut down those trees virtually right in Scanifly there. Okay, so next is drafting 3D models from scratch from those hand sketches. No need to do that. The 3D model on the right-hand side there was created automatically using the drone images. Okay, so no need to extrude up from the satellite imagery there and using those hand sketches as a reference there. No need to do that. And also too, if there's a building that has very unique architecture, right, or a unique architectural element here, like this building, so you could just quickly add panels to that unique element there very easily in Scanifly because that 3D model was created automatically for you. Okay, poll question number 3. Aside from Scanifly, what tools do you use for shade analysis?
All right, so you can see it's actually about 34% use a combination of the above. And what we've seen is it's typically you start with the remote design software and then you pick up with an on-site tool like the Suneye or the Pathfinder. I think it's very notable that about 25% combined use Suneye or Pathfinder, which have been around for some time. And about 12% don't even require a shading analysis. Those data points are different than what we've seen on past webinars. And about 21% of people are using the preliminary design software, which is typically bankable, but obviously some limitations of accuracy, as we've learned from the group and the prior polls regarding satellite imagery. Fantastic. Thanks everyone for your contribution. We're going to have 2 more polls and a few slides, and I'm going to turn it back to John.
Okay, so how can you get started in integrating drones into your workflow? So at Scanifly here, we start with an intro call, followed by a software demo. And if you are already flying drones, that's great. You can get started right away with your trial. We do have a trial period at Scanifly. So if you're not flying drones, no worries. We are here to help. We have a ton of resources to help you, including this webinar. But first things first, we recommend obtaining your Part 107 certification. So what is this Part 107 certification? So per the FAA, to fly a drone for commercial purposes, you need your Part 107 certification, and all drones need to be registered with the FAA. So the image on the left-hand side, that is a remote pilot ID that you need to have on your person when you are flying, right? When you are capturing that data, you need to have this certification, this ID on you at all times. And the image on the right-hand side, that is just an image of a serial number, registration number, excuse me, that is attached to a drone. And that is the case. So if you're flying for recreational use as well, that registration number needs to be on the drone. And it's just very simple. Let me just register your drone on the FAA website and get some tape and a marker or label maker and just attach it to the drone there. So super easy, but the registration on the drone applies for recreational use and commercial use, but the licensed remote pilot ID, right, that Part 107 certification is only required if you are flying for commercial purposes. Okay, so because you have this Part 107 certification, that means that you can fly within that 5-mile radius of a major airport. So I'm using a resource such as AirMap here to see what the airspace looks like here to assess the airspace in the New York area. JFK Airport, for example, there are areas that are close to JFK Airport where you can still fly. So this example here, this segment, you can still fly under that 200 feet ceiling here. And you're pretty close to the airport. So as long as you're not in direct line of the path here, the flight path, then it's okay. Then you can fly pretty close to the airport. But again, check your airspace, and AirMap is a great resource to do so. Okay, so next is purchasing the drone. Okay, so for less than $2,000, you could purchase a drone kit. You could purchase a drone for even cheaper than that too. For about $700 to $1,500, you can get a pretty good drone. And what drone to buy here? So we recommend the DJI drones. They have a majority market share in the consumer drone market here, and the Phantom series and the Mavic series are pretty good go-tos here. So if you're looking for ultra portability, fast setup and fast breakdown, the Mavic series and the Phantom are the way to go. The Mavic series just kind of folds in on itself and fits in a little pouch and goes in your backpack. The Phantom series, you just have to kind of secure the camera and the gimbal with a little plastic piece there, and the propellers just detach there, and it goes right in its case. So those are super easy to set up and break down. It takes less than a minute to set up and break down, I'd say, and yeah, they're really great for high volume surveys if you're doing high volume surveys. The Inspire series is more for the professional photographer, professional filmmaking. You can also attach a thermal camera to it as well. The Inspire series, there's a travel mode that the drone has to go in, and the camera has to be detached. So it takes a bit longer to set up and break down. Not recommended really for the for most site surveys, but it is a good drone there. So if you're not using a DJI drone, no worries. You can use any drone that takes geotagged images and has a camera that has a field of view of anywhere from about 90 degrees to 120 degrees there. What's important here is that the drone is taking geotagged images, right? So every time the drone is taking a picture, right, on the back end of the image, there's the geo coordinates there. That is coming from the GPS module that is embedded in the flight controller of the drone. So every time you take a picture, the lat, long, and the relative altitude is on the back end of the image, in the image's EXIF data there. So we're using that as a reference to scale that 3D model during processing. So very, very helpful and much needed information there in the metadata. So additional hardware. So if you are flying for high, if you're going for high volume surveys, there extra batteries are very, very helpful, and a car charger and other accessories are also very, very helpful. So most of the time you can do up to 7 to 10 surveys per day, depending on the time of year. But you can charge your batteries as you're going from site to site for those high volume surveys there. So most of the time you can get maybe three surveys out of one battery if the residential surveys there. Okay, so next is learning to fly specifically for solar. So at Scanifly, we have a ton of resources to help you. There's a guidebook, there are YouTube tutorials, there's webinars, and always we're here to help. We're always here to help and answer any questions if you have any. So, okay, so best practices here, image capture, best practices. So one is capture enough imagery. So we recommend anywhere from 100 to 250 images for a residential and a small commercial project. On the commercial side, 250 to 500 images, that's what we recommend. So high image overlap, okay, so we recommend greater than 85%. So in other words, if you were to print out each image on a piece of paper and place them on top of one another, so what would that, the overlap look like, or what's the percentage there? So we recommend at least 85%. On the residential side, it's more about, 90% or so. That's helpful to really capture as much detail as possible. Okay, so next is make sure you capture the oblique imagery, right? So having that camera angled at about 45 degrees or so. So the oblique image is on the left-hand side, the nadir image is on the right. So notice the oblique on the left, you could see those vertical features there, the facade of the building, the vertical features of the obstructions, right? So it's super important to have this oblique isometric view here. So you could really 3D map these vertical features as best as possible, and that's super important from a shade analysis perspective there. We need these vertical features mapped as accurately as possible. So if the camera is facing straight down, so the nadir image, or the image on the right with the nadir angle, you can hardly see the facade or any vertical features there. So those features, right, those vertical features with the nadir angle, they will appear to be kind of melting in the 3D model there. So it's not best practice to only use the nadir images. A few different flight paths here. So the point of interest path, right, that is pretty common for the oblique images, right? To identify a point of interest, which would be the center of the circle, and circling that point of interest and taking pictures there. The rasterized or grid pattern here. So the rasterized pattern, right? This path, it's mostly for the nadir angle camera there. You can fly a grid pattern with the camera angled at around 45 degrees, and that's also pretty good too. So if you've never flown a drone before, no worries. There are apps out there that allow you to fly the drone fully autonomously, where the drone takes off on its own, takes pictures on its own, and lands on its own. So Pix4D, Drone Deploy, and the Ground Station Pro by DJI, those are a few good ones. There's also the default app that comes with DJI drones, where there's intelligent flight modes there, where there's this semi-autonomous flight, right, where you control the drone where it goes, but you can set a point of interest path so it automatically circles the point of interest and takes pictures automatically. But there are a ton of apps out there. It's up to you which one you want to use. So yeah, these are just a few that we recommend. These are the most popular. So a few best practices regarding the flight paths, and I'll get into the residential one here in just a few during the software demo, but this is what we recommend, right? The oblique photos and a context flight and a detailed flight. So the context flight, right, is that larger circle there, that number one circle where the drone is flying at about 70 feet, and you're circling the building, keeping that building always in the camera's frame, and capturing the building and that surrounding environment. The detailed flights, right, two and three, that drone is flying a lot lower. Okay, we like to say about 10 feet or so above the obstructions or trees, and there's a smaller circle there. So you're really just focusing on 3D mapping that detail on the roof there. And again, I have an example of this. I'll show you in just a few. So for large commercial projects, it's recommended to use a hybrid approach, right, with on the oblique and the nadir photos. This is always helpful to capture as much detail and to overlap that data as much as possible. And for large ground mounts, right, it's also the hybrid approach is also recommended as well. Okay, so next, okay, once you have obtained your Part 107 certification, purchased your drone, and you are practicing learning how to fly for solar, you can get started with your trial. And yeah, and then you have your images, and you can upload those to Scanifly. So before before we get into the software demo, let's jump into another poll here. So how do you create permit packages?
So it looks like 51% of respondents are doing everything fully in-house. I think that's interesting because of that, only about 12% of people doing it in-house would consider third-party work. Only 5% are using a third-party provider exclusively, and there's still a good amount of people doing a combination. So I think what we're seeing here is that people still want to do as much of the permitting process in-house. Knowledge of a local jurisdiction is still probably best done by a local provider. Typically in-house, it's best. So very, very interesting takeaways, and appreciate the responses. We're going to go to our last poll question now. What software do you use to create proposals? Now, just to be clear, as you're filling this out, we are not endorsing any of these or all of these companies. From our customers' feedback, these tend to be what's commonly used in the Americas. We know there's different softwares that are used in other locations globally, but these are the common ones that we hear our customers referencing for their proposals. For us, we see a lot of the proposal tools being rooted in satellite imagery and have a lot of really outstanding features. Some of these groups have done a lot of promotion about remote proposal tools, especially during COVID-19. So it's very interesting to see what people are using. We've also seen people use a combination of them, which is why we provided that answer. So there's a lot of options in the market, and there's a lot of really fantastic software out there. So 37% of people are using proposals that are not listed. That is very interesting for us because from our conversations with customers, typically these are the ones used. So if you are using something different, feel free to send it to me in the chat. We'd love to hear what else. Perhaps it's Nearmap or PV-Syst. PV-Sol is common in Europe, but would be very interested. About 17% are using Aurora, 11% using Helioscope. We see about 27% using a combination of the above. So maybe people are using one for shading and one for layout, one because it has a nice proposal interface. But this is very interesting takeaways for us. Again, if you are using another software that's not listed here, feel free to shoot me the name of it in the chat. We'd love to learn more about that product. So thank you for your responses on all of these polls, everyone.
Okay. All right. So once you have those images, right, stored on your drone there, they're on the SD card on your drone. Okay, you can upload those to Scanifly. And so for this example, I have 159 images, and let's upload those to Scanifly. So you have your My Projects page here. So when you log into Scanifly, you have your My Projects page that has your all of your projects in a thumbnail view. And let's select a new project. Select enter your project name, select your project type, and upload those drone images. So I'm just going to select all there and just drag those over. All right, now these images here, as I mentioned before, all right, so here's your context flight. All right, so the drone is at about 70 feet AGL there. Okay, where the building is always in the camera's frame there. Just one circle around, the camera is about 45 degrees there. And yeah, that's pretty much that. And next are the detailed flights where the drone is a little lower there, okay, about 10 feet or so above those obstructions, and just one circle around those obstructions. And that's pretty much it. So just a few circles. And you can see here that once we've uploaded those images and we've pulled the location data from the back end of the image, and we can plot exactly where those images were taken here on the map. And you can see here that larger circle is that context flight, and the two smaller circles there, those are the detailed flights. All right, so once you have that, upload your thumbnail image, right, with those images behind this upload dialog box, and select upload project. And once the progress bar has reached 100%, then this upload dialog box will disappear. Now, if you do not have a drone and you want to get started right away with Scanifly, that's great. We have a network. We have a national network of pilots for hire, where if you go to request drone survey here, you can enter all of the project information and request that drone survey right here in your in your Scanifly account. And one of our FAA Part 107 certified and Scanifly vetted pilots will acquire the data for you, and then you have a virtual replica of the property ready to view in your account in no time. So it's really cool. Just wanted to mention that. Okay, doke. All right. So once your project is ready, okay, you receive an email automatically letting you know that your project is ready to view. Okay, so this is the virtual replica of the property. So the Scanifly software is 3D modeling software. So the navigation is exactly the same as SketchUp and most 3D modeling software, where you orbit and pan around and zoom in here. Right, so that's that. So in Scanifly, there are a ton of assessment tools and PV system design tools as well. So let's start with a few of the basics here. So there is a ruler tool where you can measure pretty much anything and everything. So here's the ruler there on the z-axis. Okay, you can measure this this valley there. Really cool. There's a protractor tool as well, so you can measure tilt angles of the roof. Now we're obtaining the tilt angle automatically for you, but the protractor tool is there just in case if you need it. It's there. Okay, so in the essence of time, I'm just going to load these save changes here. All right. So notice here we have all the roof planes that are outlined. There are keep outs, right? So these vent pipes that are there. There's also setbacks from keep outs there. There's also DXF export, which I'll show you here. I'll slide over. Okay, so there's a 3D view, 3D wireframe view. And notice the orthomosaic is included. Oh, let me just, there we go. Notice the orthomosaic is there, and it's to scale, right? North being north there. So if you're using 3D CAD, this is great here. So you have all of your 3D dimensions there. And the top-down view is that orthographic projection view. And if you're using AutoCAD LT, no worries. There's a 2D option here, or it's just on a 2D plane there. And this is the orthographic projection. So the ridge to eave, there will be that z-axis dimension skew there. There's also an export per plane option where you export parallel projection per plane. And notice here that the modules are one single polygon, so easy to count there. Fire setbacks are included. Keep outs are included there. Your obstructions are all there. And yeah, there is no z-axis dimension skew here because it is parallel projection per plane. It's on the normal of the plane there. That's what we're exporting on. There's also a share function, which I'll show you here, where you can share the project via a web page or a PDF with anyone. So it's a secure link where you can share your logo, screenshots, right? All the project information, company information here. So you could see here that these screenshots you could take in Scanifly at any angle with the wireframe of the obstructions, without the wireframe. It's up to you at pretty much any view there. There's also an embedded 3D model that you could share as well. So navigation is the same as Scanifly here. There's also a full screen mode there too. So this looks great on the conference room TV. You can navigate around and share with the customer what the PV system is going to look like on a virtual replica of the property. For a commercial project, you can import those inverter pads and place them in the parking lot with the fence, right? So the customer can see exactly what's going on site and how the inverter pad is going to look and how that's going to affect parking and other things there. So really cool. Production versus consumption info. There's also an option to download drone images there. Most of the time, the homeowner or the business owner will request those drone images. So you can kill two birds with one stone here and send them the project info, and also send them the drone images there. So there's also a PDF export option here. So there's a one pager with a link to the the 3D model there as well. There's also an option to share on social media, right? If you're super active on social media, there's a quick share, two quick share options for Facebook and for Twitter. And shade report PDF, which I'll get to in just a few here. So regarding the shade analysis, there are two different ways to do the shade analysis, or two different tools. Okay, let's load these changes here. Move these dimensions, there we go. So for the shade analysis, you can render shadows. So if you go on shade, go to shade tool here. So winter solstice here is the default. You can see the shadows have been rendered. And also too, notice that, I'll remove these outlines there. So notice that this project, right, the satellite imagery is super poor. The imagery is not 100% orthorectified. Okay, you can still see the facade here of this building, and there's some vegetation to the south. And notice that this is just a 2D plane, but in fact, if we just add this module, the 3D model there, you can see that there's an elevation change, which does have an impact on shading there. So the tree to the south there and the other trees will be casting a shadow on the southern roof plane, and we can render those shadows to see what it looks like. Okay, so there's that, there's the shadow rendering, and there's also generating solar access view sheds. So let's pretend that we climb the ladder and we're walking around the metal roof here, trying not to put a dent in the metal roof and making the homeowner angry. But let's just say we're standing here, we're kneeling down with the shade tool there. Okay, we can generate those solar access view sheds from anywhere within this 3D mapped environment. And we have our solar access percentage, TOF and TSRF values there. And from there, you can export a bankable shade report, which is here. Okay, so Scanifly is the only drone-based solution approved by state lenders there and organizations. Okay, so you can see that there's a the annotation here in the banner image, right, showing context and reference as to A, which roof plane this is for, and B, where the view sheds are located. There's also monthly solar access values here as well. And if there was a second roof plane, that would be there. Okay, so that's that. All right. I forgot to mention too, you could also export to SketchUp as well, and also PVSys. So there's an STL export option and an OBJ and a DAE file for that, for exporting that vectorized 3D model, the very simplified, very simple 3D model. Okie doke. All right, so let's jump into a project where there's some more context that's captured there. So for this urban environment here, the area proposed for solar is here, this building here, and the homeowner wanted to see what the impact was from this neighboring property here that's towering up there. So let's load those save changes. You could see that with Scanifly, you can add modules of different orientations per plane there, which is really fun for those Tetris style array layouts. Let's add those keep outs there. Okay, well, let's remove them. There we go. And if you go to the shade tool here, you can see that there is going to be some shade on the southern roof here, this one here, and also use the arrow on the keyboard here. There we go. And a lot of shade towards the back there on the flat roof, so there's going to be a huge impact there. So it's really important to model that surrounding environment as well as the area that is proposed for solar. And again, this 3D model was created automatically in the Scanifly software using the drone data. So small commercial project here. This project has a ton of obstructions, and so a lot going on here. You could see that the detail here, the drainage pattern. You see the topography of the roof there for drainage, and also for this roof, you could see the slope just by looking at the windows there. You can see the slope of that roof there. So a ton of obstructions. Really great looking 3D model. I'm going to load those save changes, turn these dimensions off here, and also keep outs and roof outlines. And you could see that, let's render those shadows, that there is going to be an impact. Let's move this around, there we go, on some modules here from the HVAC and from a few obstructions. And also too, look at this, this parapet wall here, very unique parapet wall. And we're rendering the shadow of the parapet wall there, making sure to keep modules away from that parapet wall. All right, which would be very difficult to 3D model if you're just extruding from satellite imagery there. So to simulate this rendering correctly would be difficult if you're just extruding from satellite imagery or just extruding in general. So go back to profile, and so let's jump into importing proposed structures, right? So we have this 3D mapped environment. Now let's import the proposed structure. So we have this 3D mapped environment that is overlaid on satellite imagery there just for georeferencing purposes only. And now let's go to the import models function. There's a Scanifly library where you can upload, or you can import rather, 3D models from our library. And one of those includes is a solar carport structure. So I'm going to load those save changes, and notice that we've added modules to the solar carports to the north there, and let's remove those dimensions there. But to the south, right, we've placed those solar carports, but there's some trees there, which were hard to tell what's really happening there in satellite imagery. So let's go to the shadow rendering function and let's render those shadows. So there's a lot happening there, a lot of shadow rendering there to the south. So those trees either have to be cut down or these solar carports are not going to be placed there. And you can even dive underneath here to see what it's going to look like underneath that structure. So it looks like all these are lining up pretty good. So that's pretty fun. It's a fun project there. All right, so I'll dive into another project here where you can import structures as well. So let's do this one here. All right, so this is a residential example where the homeowner wanted to go net zero and put an addition on their home at the same time, as well as put solar on their home. So, when I was a PV system designer, you know, it was always a challenge to design for those structures that don't exist yet. This is a great example of that, where there's an addition, and instead of extruding up from the construction drawings, you know, 9.5 times out of 10, the architect has a 3D model of that structure already, because they're using 3D modeling software when they're drafting that structure. So, you know, the addition is going to go here. So keep your eye on this area here where my cursor is, and load those save changes. Notice that we've imported the structure here from SketchUp, right? So this is an addition that the architect created in SketchUp, where, you know, they exported this as an OBJ file with texture and or material, and we can then place those modules on top of the roof plane. Very unique looking design here, but just to show you here that you can render shadows and add view sheds to that SketchUp model, which is really cool. So there's that chimney there, and here's the module there that was sticking out. So, and I'll just render those shadows just to show you that unique tilt there. There's going to be some shadows on those modules there. And also too, you can see the shadows for the modules on the existing structure. So a really cool project. There's that one there. So let's dive into a ground mount example. So this ground mount project is really fun. This is a very unique project where the topography information, well, the 3D data in general is really important here, because this is not a 2D plane, right? This is, in fact, there's a lot happening here. All right, this is a project out in the Mojave Desert where there's a cell tower and a lot happening with the topography. So let's load the save changes, and here we go. Let's remove that. And notice that when we render the shadows, let's go in an orthographic projection view here, top-down view. You can see the shadows to the north are longer, okay, and the shadows to the south there are not the same as the shadows on the northern face. So let's just adjust here. Let's go to the summer solstice here. Take this out of parallel projection view. There we go. And you can see that there is going to be an impact from the cell tower. So really cool. So we're tracking the topography there. Very fun project. All right, so the last project I'll show here is a commercial project, a larger commercial. And you can see that there's a ton of detail on the facade here, although these save changes. So it's important to map the facade on the side and the back here. So when you're placing that inverter pad, right, with the fencing around it and the discos and everything, that you can see exactly where that's going to go here. So this would be a nice place to hide that inverter pad back here, okay, and also in this corner here. And this is a great way to visualize what's happening here, and you can see the grade change. So you have to keep that in mind as well when you're building this. So that's also it's an important detail there. Conduit runs can be down the side there, but another pretty fun project to show you there. Okie doke. So I think that's pretty much it with the example projects here. Turn it over to Jason for the Q&A.
Thanks, John. Awesome. So if you have questions, feel free to email us at hello@scanifly.com. You can also use the chat box and direct questions our way. We're happy to go through any questions that you have on drones, on photogrammetry, on the software, anything that comes to mind. So I'm just going to give it a moment for questions to start coming in, and then we can just do a Q&A. Okay. So first question that we have coming in is, does the software include energy storage? The answer is no. Right now, the component related to energy storage is importing that 3D model, but it is not synchronized with the production simulator. Another question is, what is your experience in using Scanifly in Europe? Both Europe and most locations, all locations around the world, Scanifly software can be used. What's important is that we have the local weather files, which we can easily incorporate. But Scanifly can be used and is currently used all around the world. So that's not an issue at all. Okay, we've got some more questions coming in. How accurate is Scanifly's dimensions and as it relates to real world dimensions? So we always like to answer this question quantitatively and anecdotally. Drone-based 3D modeling is typically within 2 to 3 inches across the 3D model. That is driven by and limited by the consumer-grade GPS module that's embedded within the drone. That's what determines the longitude, latitude, and altitude of each drone picture. So that's ultimately what yields that 2 to 3 inches across the 3D model accuracy level. Anecdotally, we're seeing the exact accuracy that you get in your 3D model from the design be exactly what our customers are installing in the field. Our objective is to minimize all change orders and to make sure that whatever is surveyed is accurately designed and accurately installed and therefore communicated accordingly across the team and to customers. So anecdotally, we're seeing perfect accuracy across the board, and we figure customers wouldn't be using us if they didn't experience that accuracy. Another question coming in, can you customize keepouts? Yep, they are fully customizable and can be done in a variety of shapes and also customizing for fire setbacks. All right, John, I'm going to relay this question to you. It's related to LiDAR. Can LiDAR data be included in off-the-shelf drones, or is that something that's a separate type of drone or a more expensive type of drone? So, just relaying it to you, John, the question is, regarding LiDAR data and the type of drones that are used to capture LiDAR.
Yeah, so great question. So the LiDAR, it's a separate device that would be attached to a drone that could handle that payload, right? That can carry that additional payload. So the 3D scanner that we have is attached to a Matrice 600 drone. So that was the drone that can carry that payload. But The 3D scanner is typically separate. It's a separate entity from A, the drone, and also the flight controller and other sensors that are included on the drone as well. So a completely separate entity.
Yeah, and just adding to what John said, typically commercial drones that you're seeing, the Mavics and Phantoms, they're not inclusive with LiDAR. And for drone-based 3D modeling for solar, to get the accuracy you're looking for, you don't need a LiDAR scanner unless you really want to pick up some of that fine-tuned detail on, let's say, a commercial roof with obstructions, or where there's some vegetation challenges. But our customers are working across the world with all these different types of scenarios, and a typical commercial drone is more than enough. Just one more question related to accuracy in regards to how accurate is the shading tools. As John mentioned, our shading tool is the only drone-based shading tool that's been approved by a variety of U.S. state regulatory bodies like NYSERDA and Mass CEC, as well as lenders. We have seen that our output is within 1% of the Suneye, which is the other commonly used on-site shading tool. Okay, some more questions coming in. Does Scanifly have enough resolution to provide dimensions for tubular vent stacks, including the radius or diameter? So the ability to capture those kind of fine-tuned or subtle obstructions is really reliant on one's ability to fly the drone properly and take pictures from the correct altitude and angles and perspectives. But as John showed in a couple of examples, you absolutely can 3D map those highly detailed and small rooftop obstructions. So the accuracy is there. It's not entirely related to the resolution of the drone. It's a combination of how you're flying, when you're flying, the coloring of the day, what the imagery looks like, and then also the resolution of your drone. So there's a combination of factors involved. I'm going to relay this to you, John. Can Scanifly be used for maintenance with infrared drone cameras?
So not currently. So the RGB cameras only.
Yeah, building on that as well. Another question is, which camera can be used for, do we recommend for photogrammetry? The question is, do you recommend the DJI Zenmuse drone? We actually recommend a very simple, Mavic or Phantom drone. Anything that takes a geotagged image should be sufficient for 3D mapping with Scanifly. Okay, we have some more questions coming in. I'm going to combine a couple of questions regarding drone flying. There's some questions about, are the regulations for where you can fly a drone localized, and are they included in Scanifly's software? So the first part of that is yes. Every location has its own rules and regulations for flying. It's all driven by the FAA. Typically, if you're near an airport or a military base, there are stricter rules than other locations. As we said in the presentation, there's a fantastic resource called AirMap, which is how the majority of the drone industry will look at understanding the regulations for that local area. Scanifly's software does not include that breakdown of regulatory frameworks for each location, so we recommend looking at the AirMap website. And just to also clarify, Scanifly does not have a drone surveying app. We advocate for you to use the app of your choice, whether it's the DJI Go 4 app or other apps that are available out there. So that's related to regulatory framework. Okay, a couple more questions. The question is, do you see Scanifly as a replacement tool or in addition to remote design tools? That's a fantastic question. So typically we see our product being used as in addition to remote design software. We still typically see that the workflow for solar companies is to do a remote survey using satellite imagery. That gives you a rough start, whether it's Google Maps or another one of the softwares that we mentioned in one of the polls. That gives you the proposal, and that gives you kind of a rough framework for the project. Scanifly fits best when you go to the site. So typically we see our process kick in after you've had that initial conversation with satellite imagery, and it's time to start verifying on-site data. So when you do that first technical truck roll is when you'll fly your drone, you'll get the imagery that will help you close the sale, and then you finish your design through to Scanifly. And that's what we're seeing work really well for a lot of our customers. John, I'm gonna relay this question to you. Does the software create a CAD file? And if you could talk about the process by which that occurs and then how it works in CAD.
Yeah, so in Scanifly, you can export a DXF file. There are 3 different DXFs that you could export. One is a 3D wireframe. The second is a 2D wireframe. Both of those are orthographic projection, parallel views there, excuse me. And the third is a parallel projection per plane. So you're on the normal of that plane. The wireframe that's created, that's being exported as a DXF is that's a manual process currently, where you trace the roof planes, connect them together, and you add your keep outs, and that creates that wireframe, which is then exportable to DXF. Now, if you are interested in exporting that wireframe with surfaces, right, with those surface planes included, then there's also an STL, OBJ, and a DAE format export, where that includes the surfaces as well for other 3D CAD software and for importing into PVSys and other things.
We have another question regarding kind of the workflow for solar companies and how Scanifly fits into it. And this, I'm going to combine another question here. This one is in regards to, does Scanifly, can you fly the drone, or can someone else fly the drone and work with Scanifly? So typically, most of our customers are flying the drones themselves. We see that is the best way to maximize the value of this workflow. You also kind of, you can control the workflow. If you do not have a drone, or if you are not in a certain geographic area, as in, we have some customers who are expanding their territory but don't want to take on the overhead of adding a footprint and staffing people in a certain location, we can fly for you. We have a partnership of pilots that John referenced, so you can request a drone survey. But either way, all that's needed is the underlying drone pictures. Whether you fly or we fly on your behalf, all we want is the underlying pictures. You then upload those pictures to the Scanifly portal, which is in your Scanifly account. That portal and those algorithms will create a 3D model of the property and then provide you with that 3D model. And that's where you can do all of the different design and analysis features that John walked through. So that's typically how the workflow plays out. We have a couple questions about the best way to integrate drones into the workflow and how to learn and get more skills and get more training. We would advocate, the first question you want to ask is, how do I get started, is, do you have your Part 107? There's a variety of curriculum options out there, but we have a fantastic curriculum partner, Drone Pilot Ground School, that John took, and we have other customers who have used. So we're happy to get you set up with that. Other ways to learn how to fly drones, there's a variety of resources online, but we have some YouTube videos and we have a guidebook. If you go to our website, we have a resources tab that easily organizes everything. And so there's a bunch of good material there. Just a high level comment on that. We've worked with companies that have never seen a drone before in their life to all the way to the other side of the spectrum, which is they know more than we do when it comes to drones. And we've gotten every one of those types of companies up to speed and knowledgeable for using drones for their solar workflow. So wherever you are in your journey, we are happy to be a resource. Again, I would definitely direct you to our resources tab on the website. It's got a bunch of good things organized there. Question about how to become a pilot for Scanifly's network. Just let us know if you're interested. We have a list of pilots that we love to speak to if there's a request. If you are able to not just do the drone flying, but also do the internal site survey, there's really a lot of extra value with that. And then the next question that's there is, what's the typical cost for a third-party drone pilot? We're seeing pricing for solar surveys for drone pilots. So if you are the solar company hiring a drone pilot, we're seeing that be between $150 and $250 for one-offs for residential projects. For commercial projects, it could be between 250 and 500. Now, I just want to caveat all this by saying it's going to be location dependent, it's going to be market dependent, it's going to be size of the project dependent, it's going to be also be how rural the location is, and then obviously there's usually economies of scale discussion that can occur. Okay, we've been looking through a couple more questions. We do have a stop in about 2 minutes, but John and I are happy to stay on. There are still more questions coming in, so we don't mind staying on and continuing to work through them, assuming the Zoom conference doesn't close us out. Okay, I'm looking through a couple more questions. Is the Scanifly software account per individual or per company? Right now, it's per company. We have one login credential per company. We do that in part because we want this to be something that's used by all of the stakeholders at your company, right? You want the sales folks to use the shared product, to share that 3D model with your customers. You want the survey and design team to be able to produce the 3D models and create the analysis. We know the installers are using the annotations functions and the import models to look at the site before they prepare. And then people are using shading both for pre-construction, but also as-built analysis on the maintenance side. So, we want this to positively impact your entire workflow, and that's why it's per company level. Okay. Next question is, how do I enroll with Scanifly? How do you open up an account? If this is something that you're interested in exploring more with, feel free to shoot me an email. We're happy to take the conversation offline. As we showed in the onboarding process, we typically will do a call and a demo to start. And then we do offer a trial period for you to try the software. But thank you everyone for your attention, for your interest, fantastic questions. Scanifly would love to work with you on helping you integrate drones into your workflow and continuing to grow the future of solar. Thank you everyone, and be safe and best of luck. Take care.